because people do stupid things, both in research and data collection. They don't consider how valid their data is. They don't consider how reliable it is. Ignore the stats tests. Just get back to basics. Get the basics right. The rest is really, really simple. So what do you mean? Validity refers to whether a test actually assesses what it intended to assess. That's whether it's valid. So, using a bike test, I don't know, let me give you an example. Give me a better example. All right, you're going to use a Wingate test, and you say, well, we can use the Wingate test because we can use that to assess anaerobic capacity. Brilliant. Why? Well, it's 30 seconds. Yeah, but unfortunately, the anaerobic capacity lasts for about 2 minutes. So it's not valid. It might be a reliable test, or a test retest, but it's not valid for recording what you want. It's got to assess what it's meant to assess. So you have to ensure validity. It's fundamental. Okay? It's the absolute starting point for everything we do. But it is different to reliability, but validity, not surprisingly, entails specificity. Start with the specificity bit that we went through, those criteria. Is it physiologically sound, biomechanically, psychologically sound, and so on. You should then entail validity. Just make sure that, for example, yes, it assesses VO2 max, but make sure that it is a specific test for that athlete population group. So it could be a valid test of VO2 max on a bike, but you're not working with cyclists. So you've got to tie the two together. But it is different to reliability, and please do not interchange the terms. They are not the same. So reliability, produce meaningful data, feedback. The reproducibility of the test results must be good. It must be repeatable. And there is both what we call internal and external reliability. So internal reliability would be that you guys collect the data next week in the lab, and you collect it the following week with the same participant in the same labs, and you show how reliable you were. In other words, you should get the same results over those 2 weeks. That's internal. External reliability is if Loughborough then ring you up and say, we need you to come down and we need you to do the same protocol in our labs. You should be able to get the same result. So what things do you think encompass reliability? What things do you think we need to take into account even before we test to ensure reliable data?
Equipment.
Right, yeah, so what about it?
Whether it's actually functioning how it should.
Right, good. Is the equipment working? Okay, and as one student found out last year, is it turned on? Okay, sounds fundamental. Is it, yeah. What else?
Is it safe to use?
Is it safe? Absolutely. Okay, not just for the athletes, but for you. All right, is it safe? If it's not safe and you kill them, it's really not very reliable. Okay, what else?
Can we follow the same procedure method throughout?
Good. Exactly. Is the procedure identical? So we talked about, is it safe? If it was safe the first week, let's make sure it's safe the second week. If the equipment worked the first week, does it work the second week? If I collected, no, I'm going to rephrase it. If I'm doing a VO2 max test, and you've all seen VO2 maxes or had thought about them or seen on Gimp, what might make a difference is this. If I gave you encouragement throughout that VO2 max, and I shouted at you at 4 minutes, whatever, I don't know, I just shouted at you, and I get you to do it again, and I change when I give the encouragement, I've just changed the test. If I change what I say, I've changed the test, because what you don't know is how your athlete is going to react to what you say. Changes the reliability. Calibration. Last year, none of you would have thought about calibration. You probably still aren't thinking about calibration. But everything has to be calibrated. So let's think about those bikes that we used last year, those weight-loaded monocycles. How did you know that that was a kilo that you're putting on the bike each time? What told you it was a kilo?
Just said it.
Said it was a kilo. Okay? But did you know it was a kilo? No. So the only way you know it's a kilo, this is where it gets slightly philosophical, is you weigh the kilo. Is the kilo a kilo? And unfortunately, Nathan's done it. So we know which ones are a kilo. They're not absolutely a kilo. They might be 0.1 over, 0.01. But we are scientists. So we need to be known, particularly if you're doing research, you need to be absolutely exact. And here's the really cool thing. How do you know what a kilo is? And this isn't a joke, by the way. How do you know what a kilo is? Well, in Paris, they have a vault. And in that vault, it contains a piece of, I think it's lead. And that piece of lead is the kilogram. It weighs 1,000 grams. Well, here's the problem. It used to weigh 1,000 grams. Like anything, it's eroding ever so slightly. So here's the thing that will blow your mind. A kilo is no longer a kilo. A kilo is actually 999.9975 something grams. Okay, but we can call it. Right? But that's the point I'm getting at. There has to be something against which everything is calibrated. So have a think about for next week. Don't worry about it for now. What we are going to calibrate in order to make sure that you've got accurate oxygen and carbon dioxide scores. O2 consumption and CO2 production scores. And then the final thing is this. We need to think about precision. There should be a high degree of precision. There should be minimal amounts of variability. You should be accurate in what you do. So the accuracy is you. You have to be accurate. You have to be precise in what you do. Okay? And there's a lot of things to think about that are encompassed in being accurate. Whether it's the way you report the data, whether it's the way you present the data, whether it's the way you collect the data, all of those are encompassed. All of those are tied together. Okay? But what we're trying to do is we're trying to reduce the variability due to chance. There's always going to be variability because we are dealing with humans and we get biological variation. But you're trying to minimize the amount that's due to just chance. And the more precise you are, the more you control the test, the more accurate it's going to become.